My name is Kuba Gretzky. It's a huge honor to be the first speaker this year. Thank you, Dorota and Andrzej, for picking me to be actually the first person today. And today I will be talking about how a smooth C never made a skilled fisherman. I'll be talking about the toolkits that the red teams use and how it should be much better than the bad guys are using. Because the bad guys' toolkits are evolving and it should be the same in general for the red teams. So quickly about me, my name is Kuba Gretzky. I am an offensive security tools developer, also ex-MMO game hacker. I used to write bots for online games like 20 years ago where I learned all the skills that I'm using today. I also run a blog that's at breakdev.org. I write about my own research and also about the tools that I'm releasing and updating. I am the creator of Evilginx, so you can also refer to me as that Evilginx guy, like some people do, because that's what I'm mostly just known for. And I'm also releasing Evilginx Pro this year. So this is also what the talk will be mainly about. I've released Pound-Drop. That's like a Dropbox for red teams tool that I released several years ago. It is unfortunately a bit outdated right now, but I plan to do something about it and maybe integrate it with Evilginx at one point. Last year, I also started this community that's called Breakdev Red. It's a community for red teamers, and I only allow people to join who actually exist, so no anonymous access. The entrance is free, but basically every person that wants to join needs to be pre-approved to maintain the quality of content and discussions inside, and to make sure that everyone is actually on the red teams inside. I have also released a course on how to use Evilginx. I made the tool hard enough to use that I had to release the course to teach people how to do it. And here I have to say a huge thank you to every one of you who actually bought the course. I know that there are some people in the audience here, because this actually makes it possible for me to work on Evilginx Pro this year and also the last year. And this is actually why it's possible to self-fund this whole project. So, as mentioned, it all started actually at ZivCon. 7 years ago, I had a lightning talk during the lunchtime break. It was like 15 minutes. It was my first time at ZivCon, also my first cybersecurity conference, I believe, and also my first time speaking. And I had like this Wi-Fi hacking hardware that was based on Raspberry Pi with connected cables to it, and I was presenting it. And at the end, when I actually shown the credits and other things I did, I mentioned briefly Evilginx that I released just like a month before. And after I actually ended the presentation, someone from the audience actually approached me and told me, "Man, why didn't you actually talk about this project instead?" So then I thought, oh, maybe there's something there. So then apparently a lot of people actually like the project and have been using it ever since. And then later I released Evilginx second version and the third version. But what the talk is about is defenses against phishing are evolving. Phishing is getting harder. Black market phishing toolkits keep evolving, and the red teamers are essentially left alone with open source toolkits that they have to somehow glue up together and make it work. And there's a lot of effort that every red teamer has to put into making all the open source toolkits actually work. You probably know yourself. And I actually plan to help and solve this problem for everyone. And this is with the release of Evilginx Pro that supposedly will come sometime later this year. And I want to solve all the issues that actually red teams have regarding the setup, the infrastructure, the maintenance as well for it, and also the detection part. And the detection part regarding phishing, Evilginx is a reverse phishing framework, and the main issue with it is your links get detected. There is this red panel shown in Chrome when your phishing link is detected, and how to prevent scanners from accessing it. And as well, first of all, I wanted to address the elephant in the room, because I'm writing offensive security tools. So they are open source, and I'm also giving the bad guys the capability to do the bad things. So what can we do? The bad guys like phishing. The bad guys like free tools. Red teams need to simulate the bad guys. And the red teams also need the better tools than the bad guys are actually using, but we cannot give the bad guys the tools that the red teams have, which would be better than they are using. So it's basically will turn into a loop. So I was thinking, how can I actually prevent that so that I can create a tool that actually makes the red teamer lives easier, but not give it out to the bad guys. And that's why I created this Break the Threat community, like I mentioned before. That's like a vetted community for people who work specifically on red teams. And I know that they exist and they work for another company that is also red teaming. So it actually gives this good environment for people to share your TTPs and not be worried too much about them being used by bad actors. And also, Evilginx Pro will be only available once it releases to the people who actually join the community. So here I want to jump into what will be available in Evilginx Pro once it releases. On the second part of the talk, I want to also focus on one of the technical sides. So first one will be more like a bit of an advertisement about the features, and later I will actually teach you something interesting. So first of all, I redid Evilginx to have client-server architecture. So like you remember, Evilginx right now you have to SSH into a server, configure it, and it's like a client and a server in one thing. So right now it's separated. We have a client that connects to several different servers on the outside, and you can also deploy servers from the client. So there's just one command that you just set up the IP, your SSH key or the root password, set up the username, and you type in deploy. It will automatically deploy to the server that you want. No need to SSH anymore to every server just to make sure that everything is working. And also, I have added a multi-user collaboration. So now if you have several people actually working on a specific set on one campaign that, for example, encapsulates several servers, they can all connect to one server, and they can one person can create lures, like set up the campaign, set up the fishlets. The other one can actually start preparing different things, and you can all see the actions in real time together what you are doing. It's similar like a team server on any kind of C2 framework. So I have also been thinking about how to hide the API. There's also a public API that's being exposed. And you have to use a special SNI hostname to connect to Evilginx on port 443. So the whole API is pretty well hidden, because if someone doesn't know the randomly generated hostname, they will not be able to access this API. This is probably a technical detail that I'll explain sometime later. This is a set of commands that should deploy one server that you want. So you basically just add a server with the IP and its name, then you register it with the server, which is the licensing server, and then you type in deploy, and that should be it. Now also Evilginx, because it's a client server, it has a client server architecture. It has the full API that's accessible through HTTP requests or persistent WebSocket connections. And here's a sample of the response that you get from the Evilginx server to grab the list of sessions. So I'm really eager to see if the community in the future will try to use it to automate some of the stuff that Evilginx is doing, and maybe use some kind of this AI hype to do phishing automation or whatever. There's also Evilpuppet, which is the module that I also talked about last year. This is a background browser that's controllable with fishlets. And essentially what it allows you to extract specific shadow tokens from the legitimate session that's running in the background. I covered it a bit in the other talks, but here you can see that it will trigger when the phished user is actually approaching this path that is being outlined here, it will open the login page in the background browser, grab the username that the user entered in real time on the phishing session in their own browser, then type it in and also type in the password and later click the button to submit. And once the post request actually is initiated, it will grab this shadow token that is crucial to inject into the reverse proxy session to not get the account blocked, because it contains browser telemetry that has to be retrieved from the legitimate browser. That should probably be a separate talk, so I'll just talk about it a bit briefly here. There's also a reverse proxy as a website's spoofer. So for now, all of the unauthorized requests to Evilginx actually resulted in the redirection to the Rickroll video or the other website that you specified. But this time you can actually proxy another website the same way as in general Evilginx works. It will reverse proxy the content from another website and show it in context of the phishing domain that you are using. So this is a bit more convenient. Because it allows you to present that your phishing domain is actually hosting a legitimate website, and you don't have to put like some kind of static content that can be easily fingerprintable. You can specify whichever URL you want. So here, as an example, I used the Cameron's World website that is being proxied through linkedin.fake.com. Another thing, TLS wildcard certificates. So you know that Evilginx currently is able to retrieve and renew certificates from Let's Encrypt, but all the TLS certificates are registered for the full hostname with the subdomain. And this is actually an issue because every time you ever register a TLS certificate, maybe some of you don't know because I didn't know before, this certificate gets published in the TLS transparency log, which is publicly accessible worldwide. So all of the bots and scanners that try to look for phishing URLs and scan the phishing links will retrieve the domains from there and start looking if this is a website that's hosting a fake login page or whatever. And that's when the scanning begins. So with the wildcard certificates, this problem just vanishes because the wildcard certificate will hide the subdomain that you are using in your hostname. So the bots would have to brute force the subdomain to find your hostname. So this actually prevents the majority of scannings from the bots worldwide. There is also automated JavaScript obfuscation implemented. I use the engine that's hosted on obfuscated.io, and every injected script into the landing page that you're using in your fishlets, or it's a JavaScript that's injected to handle the redirection to the real website afterwards, after the phishing is a success, every script is actually dynamically obfuscated. It's cached for 5 minutes, and then it re-obfuscates it, but it actually prevents any kind of scanners to fingerprint the scripts that you want to inject into your phishing landing pages and protect them from signature matching. Then I have also rewritten the database to SQLite. Before it was BondDB. It was a long time ago, before actually there was no SQL driver for Go to be written natively. You had to use C and compile it through the C libraries, and it would then rely on the libc version, so it was hard to make one binary that would work on all distributions. So sorry, Melvin, I don't know if Melvin made it today, but you'll have to probably rewrite the bobber. This is like a very nice thing that Melvin from TrustedSec actually released and made like this triforce of 3 tools working together, and it was reliant on actually retrieving the data from the BondDB database. Another thing, it's the external DNS management. For now, Evilginx had a local name server working on the same host as the phishing server. So you had to point the phishing domain that you registered, you had to point the name servers to the IP of the Evilginx server, which was kind of suspicious, and probably if someone looked into it, it would be pretty much easy to tell that it is like a phishing instance that's just hosting the name server on the same IP as the phishing server. And now you can actually avoid that, and Evilginx supports the use of external DNS providers like Cloudflare, DigitalOcean, and Route 53 for now, AWS, and more will come. So basically, all of this is doable through the libDNS library that actually provides like this interface for any API that I can put into it. So let me know later if there's any DNS provider that you want implemented that you are using on a daily basis, and this will give me great feedback. And now we go into JA4 signature spoofing. So first of all, I wanted to ask how many of you know what is JA4 or JA3? Okay, great. That may be interesting. So this is something that came up like a pretty new thing. So basically, it is used to fingerprint the software that is being initiating the TLS handshake and establishing the TLS connection. So what I did, I implemented the spoofing of this, but let's dive now deeper to the more technical part of this talk and talk more about JA4. So JA4 Plus is essentially like a suite of network fingerprinting algorithms, you could say. Like it generates signatures for several different types of handshakes that you can use, but we will be focusing in this talk only on the TLS handshake. And more specifically, of course, I have to credit, it was made by John Althouse, the JA4 from Fox.io, a really great guy. I talked to him briefly about a few things. And it is a successor to JA3. JA3, I think, was released by a different company before, and now John is releasing JA4 under his own company, if I'm not mistaken. So in general, the JA4 is a signature generated from the TLS handshake client hello packet. So if you know, like this is the client hello packet gives the server the information. What is the TLS version it supports? What is the ALPN? So if the client that's initiating the TLS connection supports HTTP 1.1, or does it also support HTTP 2 or even QUIC? That is also embedded in this client hello packet. It lists all the supported cipher suites with which the secure communication will be established. And it also lists the list of TLS extensions that are used. And one of the TLS extensions that you probably are familiar with is the SNI extension, which actually outputs the host name of the server that you are connecting to. So basically, it gives the firewalls the ability to tell what domain the client is trying to connect to before the connection is actually encrypted. So this is sent in plain text, so it can be intercepted and scanned. This is how the JA4 fingerprint signature looks like. It's divided into 3 sections. There is a A section, B section, and a C section, no pun intended. And the first section actually tells you what is the TCP, what is the protocol, TLS version, if it supports SNI on the hostname or the IP, number of cipher suites, and the other things. The second part, the B part, is what we will be mostly focusing on. And this actually tells what is the list of, it sorts the list of all the codes for all the cipher suites and creates a signature out of them, like it hashes the full set of these, of the list of these codes. And the third section that we will not be focusing on is just a hash of all the extensions that are being sent in the client hello packet. So this is a screenshot from Wireshark. And in Wireshark, you can see that the client hello packet, so this is basically the reading of what the client hello packet looks like in Wireshark. You can take a look yourself when you have free time, and this is where the cipher suites are listed, and this is the list of extensions. This is when I expanded the dropdown. You can see the codes for each cipher suite, which are being used to generate this signature. So the J4 in raw form, you can see that the first section before the underscore is the same because it just has information about the other characteristics of the connection. But the second B part is just a list of all of the codes for the cipher suites. And later it is, there's I think the SHA-256 hash, I think, taken out of it and truncated into 12 characters. So here let's take a look. What are the most common applications what are their J4 signatures? And here you can take a look at Google Chrome, for example, which is, take only look at the middle section, at the B section, because the other ones will vary, will be different too often. And what I want you to take a closer look at is the Sliver malware and Evilginx. Like, you can tell that the middle section is the same. And the funny thing is, they are both written in Go language. So they use the same Go TLS library, which has the same list of supported cipher suites. And if you do not change it, you can basically fingerprint every software that's connecting to you that was written in Go language. So this is like a clear way to block Evilginx from talking to the destination server that attackers are trying to attack. So scouting for prey, the Google Chrome J4B signature is this one. You can remember it because it will be mentioned later in the talk. There is also this Golang signature that I mentioned. And you can think, like, who actually uses J3 or J4? Is there any service? And basically, Cloudflare, of course, is using it. I had an issue with Evilginx previously, I think like a year ago when I did some tests. And whenever a page was actually protected with Cloudflare, immediately when I went into the phishing page that was proxied by Evilginx, I got presented with the CAPTCHA that I had to solve. And I had no idea why or how exactly it is happening because it made no sense. And later, when I actually customized and modified several of the cipher suites that the Go is using, and I just added, I think, 2, removed a few, then this CAPTCHA stopped appearing. So it actually proven to me that Cloudflare is doing this kind of thing, scanning for J3 or J4 signatures. So what can be done in terms of the attackers? How can we prevent the hunters from basically, well, not the hunters, but how can we prevent the destination server from knowing that they are using Evilginx? So this is basically what I mentioned. You can modify the list of supported TLS ciphers if you need. And also there is this UTLS library that I implemented into Evilginx Pro that basically will randomize the list of cipher suites every time the connection is made to prevent any form of blacklisting of the J4 signature. So it gives you different J4 signature with every TLS connection. And it's also good to avoid J4 blacklists. So this is enough until defenders deploy more advanced detections, and probably they will. I even have a few ideas, maybe not a good idea to share them right now, but there's also another option. When a client connects to the phishing server, which hosts Evilginx, you can actually grab the TLS client hello packet that's coming from the client's browser, and you can copy the list of the cipher suites into the connection that Evilginx is making to the destination server, so that it actually mimics the client the real client to the server. So then I had the idea, if the servers can actually detect Evilginx, what about actually detecting who is connecting to Evilginx itself, like all the bots that are actually scanning the phishing links and things like that? Is it possible to actually harness the power of J4 to actually make it in reverse and make the hunters become the hunted? So then you basically have Evilginx becoming the defender, and the tables have turned. So So basically, I decided that it would be maybe a good idea to reinvent the wheel, because why not? Like this, it's always a great idea. So Cloudflare is already great at detecting the bots. This is like their entire business model. So basically, let's try to see what Cloudflare is great at and do the same thing. There's a Cloudflare turnstile that you can use with Evilginx. This is like mainly their service to detect bots in real time to prevent you also from showing the CAPTCHA. It only shows the CAPTCHA whenever it detects some anomalies. You can check it out. I made like a proof of concept that you can actually use turnstile with Evilginx as a redirector, so it will protect your phishing pages with turnstile. But why not implement our own bot guard that would be available in Evilginx Pro like by default? And behold, it's a poor man's Cloudflare idea. So it's like a very cheap version probably, but I decided to do it properly and prepare with some kind of research. So I forked the Go vhost library that I've been using to extract the host names from the SNI extension data. And I added the code to generate J4 signatures for every connection that's actually coming into Evilginx, because the code for Go was not publicly available, so I used the documentation that John Althaus published and wrote my own signature calculation code. And then I set up the logging so that every time I got the connection to Evilginx, I would log the IP, J4, some additional telemetry that I will talk about a bit later, and then I will have some data set to analyze later. Later, I also disabled the usage of wildcard certificates because, like I told you, if you don't use wildcard certificates, the bots will immediately start scanning your server, and that was that's what I wanted to do for a change. So basically, I wanted every bot to scan my website while I was gathering as much data as possible. I also uploaded the phishing link to every URL scanning service I could find, like VirusTotal, others that I found randomly on the internet, and then I waited. So I gathered the data for a bit, like 1 month, and what were the results? I got like a total of 820 requests to my phishing links, and also to phishing domains, and they came from 680 unique IPs. So you can see like what is the percentage of unique IPs being used. And this actually also proven to me that IP blacklisting is dead these days. It's like, I even saw one bot scanning my page in real time. It was scanning this spoofed page that I was actually retrieving from the external resource, and it was scanning every single URL it found in the HTML content, and the origin IP was different with every request. So they are definitely using IP rotating services. So IP blacklisting basically makes no sense these days. I've also logged the ASNs for every IP that I got, just in case I could see some kind of maybe patterns of what organizations use what IP ranges, and maybe just scan, I don't know, I saw Palo Alto ASN or others. But essentially, there were too many to make any kind of reliable information out of it. And here, like a plug for IP info, like thanks to these guys, because they release free databases of ASNs and also IP to geolocation, which they update daily. And you can just download it and use it in your own projects, which is pretty amazing. So the most popular J4B signatures that I encountered during this test. And this is actually it was actually pretty sad to see, because 80% of all requests came from Google Chrome, which they had like the J4B signature. There were only like 11% of requests originating from Go software. And the Googlebot, because it advertised itself in the user agent, was just 1%, and it also has the unique J4 signature. So the result, it was a partial failure. The J4 signatures on their own are not enough to detect bots, unfortunately, because most bots use the Chromium engine, like the headless browsers and things like that. But then I had a new idea. Like, all the phished users that you are actually attacking as a red team, must have JavaScript enabled, because otherwise the login page will not work. Like, JavaScript is everywhere these days. So it is safe to assume that JavaScript will always be available on the target system. How many bots actually are able to run JavaScript? And that's what I wanted to find out. So before I also started this, I started gathering telemetry through the injected JavaScript that I had in every landing page of my phishing server. And it would report back the telemetry to the Evilginx server for analysis in real time, like through the AJAX request. Then Evilginx actually analyzes it, and then spits back information as a response, whether it's allowed or not for this user to connect. And the question was, like, how many page views out of this whole 820 resulted in telemetry data being sent back to the Evilginx server, which meant how many of these bots actually did run JavaScript. And the answer was 35. So that was pretty amazing, like how these bots work and how like little of them actually have JavaScript enabled. So then I began analyzing browser telemetry that actually got returned to Evilginx. So I decided to go for the low-hanging fruit, because that probably would result in the less false positives, and there were like really tons of. I also mentioned, I think, there's the FP collect library that I used to collect this information in JavaScript. Then I decided to analyze the telemetry, and I would get the browser window size and the user agent. For analyzing the user agent, I used the UA parser library that you can see a link to here. It would only help me to grab the name of the browser, OS, and the version. So first I started with window size analysis. So that may seem a bit like a joke, but it was actually interesting to see that most of basically, browser window is divided into two specific sets. It's the inner window and the outer window. The inner window is what you see except for the toolbar and the edges, I believe, and the outer window is what you have as a full window of what you are running. And most of the bots actually seems to be using a very generic screen dimensions, and they all are running in full screen mode. I tested on my own PC, and you can only get these kind of results if you actually type in F11 in Chrome to put the page into full screen. So it was pretty unlikely that you would be phishing a target who uses like exclusively a browser in full screen mode. I don't know if you maybe encountered any cases like that, but to me it seems pretty unlikely. So this is like the first thing that I started to detect. Then there was also another case that the outer window was actually smaller than the inner window. Like, how is it possible? How can you make the window smaller and the inner window bigger? That made no sense. So I started Googling it a bit, and apparently you can do it when you zoom out the page with Control and minus. But then also the device pixel ratio gets below 1. And every bot actually reported that the device pixel ratio to be always 1, and it never changed. So this was another like a signature that something was suspicious about the browser that's connecting to your website. Another thing was unnatural, unrealistic window sizes. Outer window of size 1 pixel, that just is pretty much not possible. And then I began to do the browser version analysis. And I could see that almost all, like I'm talking about 95% probably of all browsers that ever contacted Evilginx had outdated browser versions. So defenders, if you're like writing the bots, just make sure to like at least keep the user agent updated with all the updates, because it's really the lowest hanging fruit, because it is very unlikely for any request to come from the browser that is 6 months older or anything. Then there was this interesting case that I found, and I couldn't tell I knew that it is a bot because it used the link that I specifically prepared for the bots. And it actually reported an iPhone running the Safari browser connecting to my server. And the window dimensions looked pretty okay. I don't know what are the dimensions of the iPhone phone. Maybe you can like figure out if it's something is fishy about it. Then the version was pretty up to date. And I was thinking, what else can I look into? So I looked at the other telemetry that was also gathered, and I saw like the video card data. The video card was made by Google, and it was angled, and I later Googled this angle thing, and I think I saw, if I remember correctly, it was only for Android devices, essentially. And then I also compared it with the JA4 signature that I also captured, and it told me that it was actually Chromium engine connecting. So it was not really Safari on the iPhone. I could tell by cross-checking all this data that I gathered that it was actually a fake user agent. So was not Safari really. So the real detection power comes from cross-checking all this data through all different sensors. So JA4 actually was not useless in this situation. It serves as a really great addition to what you can do for detecting the bots. So here I set up a bit of like a customization for Evilginx Pro, where you can set up your own YAML script and to blacklist specific JA4 signatures, or you can set up what versions of major browsers you allow. And all of that will be all the other requests will basically be shown this generic website that you are redirecting from a different site to actually fool the user that there is no phishing involved. So here I wanted to tell you to contact me later after the talk and let me know. Probably best to also contact me on the email with the subject ZivCon Breakdev. If you are on the red team and you want to join the great community of red teamers and want to share information, it would be great to have you. And everyone is invited, especially from the ZivCon crowd, because then I can confirm you really exist, so it will be much easier. So Evilginx Pro is actually coming soon, later this year. And how much time do we have still left? 10 minutes, okay. So if we have 10 minutes, I can actually show you maybe a small live demo, if I manage to. Okay, so this is the client of Evilginx Pro. So you can see right now it is running on the local machine. And I can actually list all the servers that are being supported by, that are configured right now. And you'll be able to connect to each one of them one by one. So here I connected to the local server. Then I connect to another server that I have on the list. And this shows you how quickly you can move from one server to another. And you can check the information and set up based on all of the servers separately. So this gives you like a quick idea of what to do. And here we'll try to make, if we have some more time, I'll actually try to make a demo because I wanted to show you something interesting. So here I prepared a link for ZivCon presentation. Okay, so I'm opening the page. It is also now checking the bot guard. You can check that the bot guard check passed. So that was actually when it gathered the telemetry in the background, reported it back to Evilginx, and returned back the response that, okay, it is fine to show the phishing website. Let's just prepare. Okay, so we got the capture. Now I have to. So I got the approval request for the MFA that I need to accept. Okay, we are signed in. And okay, we can see that the authorization tokens got accepted, so the phishing worked. And now you can list the session. It is also in the demo mode right now, so you cannot see the password. It's just filled with asterisks. And I will copy the cookies that were captured. Now I will clear the browsing data to show you how I import the cookies from the intercepted and the captured session. And now when I open the live.com, which is the real website, this cookie actually provides me access to the target's account. And this is essentially how Evilginx worked for the last 7 years. But there is one thing that I wanted to show you as a maybe like a funny thing, because when I sign out from live.com, which is the official Microsoft website, I sign out. Okay, you can see that the website is actually correctly not logging me in. But then when I import the cookies again, tell me what should happen. We're logged back in again. So Microsoft, you do not only invalidate the session tokens on the client side, you need to invalidate them also on the server, so to make it work much more secure. So basically, that's the end of the talk. Thank you. If you have any questions, I will be free later. And I have stickers as well. So.